All right. Hello, everybody. Happy Tuesday evening, which is when I'm recording this. We won't be having class tomorrow, but I wanted to go through number one, this set of interactive models that we covered in class. Um, wow, whenever we met last week. Hopefully, we'll be back together on Friday of this week. I'd given you the circular flow diagram, which you can interact with and click on. Um, Dollars, of course, flow in the green arrow direction, and goods, services, and factors of production flow in the red arrow direction. You have firms and households that meet in markets for goods and services and for factors of production. But the model I wanted to talk about is on the second tab, which is the production possibilities frontier, which we mentioned second. And I asked you two questions, which a lot of you, but not all of you, have answered yet on the Google form that I sent around. And the first question was, at a production level of 45 barrels of wine and 95 wheels of cheese, is it possible? And so we have these interactive sliders. We can set the wine production to 45, and we can set the cheese production to 95. And we can see that that is unattainable because this point lies outside our PPF, outside the production possibilities frontier. Anything in this pink region is unattainable. Anything in this green region is attainable. And anything on the line is, you can think of as the machine running at full capacity, doing as much as it can. We can look at where it intercepts each axis. If we put all of our resources into making cheese and we make no wine, we make zero wine, we can make 100 wheels of cheese. And by comparison, if we put all of our resources into making wine and we make zero cheese, we can make 100 units of that. The second question I asked was, what about 60 barrels of wine? And what about 60 wheels of cheese? Is that possible? And the answer is yes, because it lies inside the production possibilities frontier curve. But is that efficient? It is not. We could run the machine a little faster, which is to say we could either have more wine, we could have more cheese, or we could have a little bit more of both. So let's say we absolutely wanted 60 barrels of wine. That was our bare minimum, but also as much as we needed, and we wanted to maximize cheese. We could be making more cheese. Here we're moving the dots, moving up this axis, and we could produce, looks like all the way up to about 80. So that would be both possible and an efficient outcome. Let's look at a few slides. I'm not going to keep you too long. This was one of the last production, this is one of the last slides that I showed you last time, which was the production possibility frontier for airplanes versus soybeans. And this table is graphed on the following slide. And this frontier doesn't jut outward. That is to say, there's not a change, a marginal change in the opportunity cost for producing soybeans versus airplanes as we've drawn the graph here. So for example, we can draw some more points here. F is impossible. That represents a point of trying to farm 4,000 tons of soybeans. It looks like make about 80 airplanes. Does that mean we can't make 4,000 tons of soybeans? No, we can, but by using up all of our resources in that industry, the best we could do is produce 20 airplanes. Or could we produce 80 airplanes? Yes, we can, but because we'll be taking up those resources, we can only devote 1,000, we can only get 1,000 tons of soybeans because of our resource constraint. The shape of the curve, the frontier, the actual edge of the curve, is not constant in our cars and computers example. And it reflects in the fact that it bulges out. So I just want to make that point here. This is obviously not a linear curve. And let's look at one point where the opportunity cost of a car is highest. It is highest when the economy is producing many cars. That would be something down towards this end because we're producing cars on the x-axis. And let's see that by looking at starting at this point where we're producing, I don't know, it looks like about 900 cars and just under 1,000 computers. And then let's say we make a change instead of going from this point, which I haven't labeled, but it's the upper right hand edge of this triangle that just tells us how many computers and how many cars. I said triangle, rectangle that tells us how many computers, how many cars. Um, if we want to incrementally make an extra car or a few extra cars in this case, we have to sacrifice many computers. So let's look at that. Let's move from this level of production to about where E is, this level of production. What is happening in that region? Well, are we getting more cars? Yes, we are. How many more cars? Well, the distance between these two vertical lines, these two braces. How many computers are we losing? Well, we're giving up relatively a lot more computers. So in this region, the opportunity of a car is highest. Um, at the other end of the curve, the opportunity cost of a car is lower, but the opportunity of a cost, when the opportunity cost of a car is lower, the opportunity cost of a computer is higher because of how we've drawn the curve, which is to say, if we want to make a lot more cars, let's say go from 0 cars to this point F, we only have to give up a few computers. So we get a lot of cars for a few computers, as opposed to this situation where we only get a few cars, but have to give up a lot of computers. So that's really all the point I want to make about the PPF, and I want to keep you thinking about it. I feel very certain we'll be back on class on Friday. I look forward to seeing you then.